All right, so let's try to predict the molecular geometry of more complicated molecules. A lot of the times, whenever we have more complicated molecules, we're either dealing with polyatomic ions or things that have expanded octets. And so let's go through an example of an expanded octet that is relatively easy to follow along, and that is XeCl4. And so whenever we do this, we have to first always draw the Lewis dot structure. And so whenever we do this, we have to predict the Lewis dot structure of XeCl4. And so this is where we have to always use formal charges again. And so in this case, our first step for formal charges is finding out how many are our total valence electrons. And so this is going to be equal to 1xe plus 4 Cls. And that is equal to 1 times 8 plus 4 times 7. And so that is 28 plus 8, which is equal to 36 electrons. Then our job at that point is to be able to predict our structure of XeCl4. So if we draw this real fast, we have Xe. This is our central atom, so we have Xe. And our first step for whenever we do formal charges is to assume we have single bonds attached to every single one of our outer elements. And so we have a Cl, 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 and Cl. And then what we do after step 1, so draw LDS with single bonds. Our step 3 is to make sure that outer elements have 8 electrons each. So a good rule of thumb is that your outer elements, even though Cl technically has the potential to have an expanded octet, outer elements will never have an expanded octet, and they will always be 8. And so in this case, what we could look at is Cl right now has 2 electrons, and so we need to have 8 electrons. We need to add additional 6 dots to the outside. And so we do that real fast for every single one of these where they have 6 dots. Right, so I'll redraw this one. And then we count how many electrons we have so far in our drawing. So right now we have 1, 2, 3, 4 pairs or 8 electrons attached to our chlorine. And if we have 4 chlorines, that is a total of 32 electrons right now. So this drawing has 32 electrons. But what we've said earlier is that we need an additional or a total of 36 electrons. And so I guess step 4 is add leftovers to center. And so we have an additional 4 electrons or 2 lone pairs that need to be attached to our Xe. And so that's what we do right here. And so we have 4 dots attached to our central atom. Then what we do is find the formal charges. And if we need to, rearrange it so that we have double bonds, single bonds, or triple bonds in order for everything to get to as close enough to 0. So get to 0. In this case, we'll have to do 0 or no rearranging because you'll see in a little bit the formal charges of each of these elements. So let's look at the formal charge of chlorine, right? So each of these chlorines are the exact same thing where it's 1 bond and 6 dots. And so let's calculate the formal charge or formal charge of each of these things. Remember, formal charge is equal to valence electrons minus non-bonded electrons minus bonds. And so if we look at the formal charge of chlorine, its formal charge is equal to chlorine has 7 valence electrons minus each one has 1, 2, 3, 4, 5, 6 non-bonded electrons minus 1 bond, and so it has a formal charge of 0. And so each of these chlorines have a 0 overall charge. Then we look at our central atom, Xe, and we find out its formal charge. So Xe has 8 valence electrons. Right now it has 1, 2, 3, 4 dots, so it has 4 non-bonded electrons, minus 1, 2, 3, 4 bonds, and so it also has a 0 overall charge. And so what do you know? Our base structure that we've drawn so far for XeCl4 has everything as a 0 charge or 0 formal charge, and so we have already drawn the correct Lewis dot structure of XeCl4. And so then what we could do is step 2 for figuring out the molecular geometry is finding out how many electron pairs we have. And remember the way we find how many electron pairs we have. So electron pairs is equal to your number of bonds plus your number of lone pairs. And remember, we're only looking at our central atom. And so we're only looking at Xe in this case. We're not looking at anything else. We're not looking at Cl, just Xe. And so let's look at the electron pairs of Xe. And so if we look at this, Xe has 1, 2, 3, 4 bonds. Plus, it has 1, 2 lone pairs. And so we have a total of 6 electron pairs associated to Xe. And then, like we described earlier, we have 1, 2, 3, 4 dots, which is exactly 2 lone pairs. And so all we do now is step 3 is find the molecular geometry using the chart. And so what we have to do is match the drawing or molecular geometry that has 6 electron pairs and 2 lone pairs. And if we look at the chart, this is equal to a square planar molecule. And so our molecular geometry is square planar. And if you want to redraw this, you have Xe in the middle. And so all you do is recopy the drawing that you have. Instead, replace it with our elements. So we have Cl, Cl, dashes for another Cl in the back, dashes for another Cl in the back. We have a line up top for our lone pair, line down to the bottom for our lone pair, and then all we do is copy over our dots over to each of our Cls. And there you go, we have the Lewis dot structure or molecular geometry diagram of XeCl4. That is once again a square planar molecular geometry.